Introduction to functional groups. So the number of organic compounds is limitless. Well, I mean, not necessarily 100% limitless, but pretty much. So this makes our life pretty difficult because there are so many different compounds. Now, however, when specific groups of atoms are in a specific arrangement, they have very similar chemistry, regardless of the rest of the molecule. What do we mean by that? We would say that this compound, referred to as an alcohol, would have the same chemistry as this compound, solely because it happens to have an OH group attached to a carbon. These arrangements are called functional groups. So when we are shown an organic compound, you want to focus pretty much on the functional groups or the single functional group that is present, because that is where the action happens. So functional group where action happens, which of course means that you need to be aware of all the functional groups so that we can recognize what functional groups are present on each molecule. And furthermore, if we know the reactivity of the functional group, we know the reactivity of the compound itself. And that is a powerful tool. So if there's a limited number of compounds but a limited number of functional groups, if we can recognize the functional group, we can decide what the chemistry is going to be. Alright. Just a note to itself though, so we can summarize the non-necessary parts of a compound so that we don't have to keep drawing them, such as in this example, if we have a short chain alcohol, we'll learn what alcohols are in a bit. This compound, you will notice that they all have an OH group. Even the ones up here, they all have an OH group. Well, we can summarize every single one of those compounds with just ROH, where R is the carbon framework that is not crucial to the system. Alright, so I'm going to fill out a table with all of the different functional groups. We'll start with the simple one. Alkane is pretty much the absence of a functional group. You will have a carbon-hydrogen chain, such as shown in the example, and the general formula is literally R, whatever the carbon framework is, with hydrogen attached to it. Now, any chemistry happening on a carbon-hydrogen bond is actually advanced chemistry. So alkane chemistry, even though it's the first thing you learn, is probably the last thing you're going to learn the reactivity of. We then have alkenes, where we encounter a double bond. So here we have butene. The general formula is of the like. Now, of course, the double bond can be at different positions, so you could have an internal double bond in the general formula also. You have the alkyne, where it is a triple bond, also referred to as R triple bond. That doesn't make sense, but don't worry about that. We'll keep moving. You have arenes, where the most common example is benzene. This is what we would refer to as aromatic rings. You actually shorthand that with ARH. So say we had a ring, an arene with an alcohol on it. Keep repeating alcohol, we haven't even covered that yet, but you would say AROH. AR being this part. Cool. Let's get rid of that so that it's not in our way. We can then keep moving. Alrighty. Next one you need to learn is the alkyl or alkyl halide. So alkyl is just when you have an alkane attached to something. So an alkyl halide, well, obviously has to have a halide. So say ACl. Generally speaking, the structure would be RCl. But of course, as long as there's an alkane chain, it is an alkyl halide. We then have alcohols. Finally getting to that, so we should be familiar with that one already, is with the OH group. General formula being ROH. We then have ethers, which are similar to this compound. It is pretty much, instead of a hydrogen on the alcohol, we end up having an alkyl group attached to the oxygen. Alright, general structure, or general formula being ROR. We then have amines. Amines have a nitrogen in them, usually an NH2, although it could be something more. So N R₂NH2, but it could also be RNR with an H, or RNR with 3 R's on it. Notice that all those nitrogens have 3 bonds. They are still all referred to as amine. We then have aldehyde, which looks something like this. You would say the R group with the general structure. Notice that it is pretty much a carbon double bond to an oxygen with a hydrogen on it. That is the aldehyde part. If it does not have the hydrogen, it is not an aldehyde. It must have that hydrogen. Alright, let's get rid of that. Moving on. We then have ketones, which most people always confuse with aldehydes because they are very similar, but a ketone does have this carbon-oxygen double bond, but now attached to the carbon, you will notice that both sides have a carbon attached to it. It is usually shorthanded to R, carbonyl R. Guess shorthand. Oh, what am I doing? I don't know what I'm doing. Sorry, guys. Just a refresher, because you've probably never seen it before. Carbonyl is the carbon-oxygen double bond with something attached on these sides. So I will often refer to the carbonyl. Recall this part as the carbonyl. The other things attached to it change the functionality of it. As we have just seen, the aldehyde requires a hydrogen on it. The ketone requires a carbon instead of a hydrogen attached to it. Alright, moving on. We have carboxylic acids. These are acidic, And most organic acids tend to be carboxylic acids, hence the name. It has a carbonyl and an OH, so it's kind of like an aldehyde with an extra oxygen in it. That is not a coincidence. The general formula would be something like this. We then have acyl, again, Sammy. We have acyl chloride. There's an interesting point here. Notice that the name sounds similar to an alkyl halide. Well, that's not a coincidence either. Acyl is the carbonyl part, so that attached to a chloride will give you an acyl chloride. If you look at the general formula, it's R, carbonyl, and a chloride, acyl chloride. You then have acid anhydride. This one is pretty much the dehydrated version of a carboxylic acid. It looks similar to this. General form being R, carbonyl, oxygen, carbonyl, R. We'll get back to those, but you pretty much just need 2 carboxylic acids. You remove a water, and you're left with the anhydride. We have a couple more. We have the ester, just like your grandma's name, ester. An ester would be a carbonyl coordinated to an alcohol. Notice the oxygen has carbons attached to it, general formula being R, O, O, R. You have the amide. Notice that it is a carbonyl with an amine, makes an amide. And then we have nitrile, where you will have your cyanide structure. So R, C triple bond N is a nitrile. Nitrile gloves contain those bad boys. Now, of course, this has been a list of just single functional groups in a compound, but compounds tend to have more than one. So we will look at some examples. One functional group. So as an example, here we have one of the more common amino acids. Notice that we have an amine and we happen to have a carboxylic acid, hence an amino acid. Whoa, what is this thing doing? Amino acid, and that is where amino acids get their name. Alright, I recommend that you look at the following structure of vanillin, and then on a piece of paper circle, well, redraw it obviously, and then circle each functional group that is present. This is vanillin. It is literally the flavor of vanilla. I highly recommend you pause the video right now, draw it out, circle all the functional groups that you think are present, and then when you are ready, continue with this video. Okay, now that you have drawn it successfully, I hope, we have an aldehyde, we have the arene, which technically is a functional group, we have the alcohol, and we happen to also have an ester here. Sorry, not an ester, an ether. Damn, see, been doing this for 12 years and I still don't remember them all. Alright, it's false, I remember them all. Just making myself look bad. Alright, I hope you got all of those right. This is the kind of question that you will get in exams, so I cannot emphasize it enough. Learn all the functional groups. If you can recognize animals, you should be able to recognize functional groups. Alright, good luck. Have fun learning.